Hello YouTube, my name is Adam, and I'd like to do a short video on 7-segment LEDs and with the Arduino Uno. So here we have an Arduino Uno with a breadboard shield attached. The I/O pins slide in there nicely, so it's real easy for you to prototype. So a friend of mine gave me some 7-segment LEDs, and they have two decimal point places actually. And I couldn't find a pinout at all online for them, so I had to draw it up myself. And also had to figure out if it was common anode or common cathode. Anode is plus 5 volts, and then cathode is negative 5 volts, or actually ground, which means you supply voltage to the segments, and then the voltage goes to ground with the common cathode, but with the common anode, you supply the 5 volts, and then it goes to ground through the segments, which lights it. So, in order to figure out what this diagram is, you get a multimeter, put your leads on common and voltage, black and red. And then what you want to do is put the selector on continuity. You also see a picture of a diode there, which is what LEDs are. And then you can do a quick test with your leads. Okay, so you know it's working. Okay, so I have my multimeter in diode mode, and now I have the light turned low, my positive, and start testing pins. Basically, you're just kind of moving them. Make sure you get them in there good. You're looking for something to light up here. And in this case, it depends where you're applying the voltage, if something will light up or not. This is why finding the pinout for your device is a lot better. Okay, so here I found continuity between two sides of the 7 segments, so that means most 7 segments have a common anode or cathode, one on each side, or 2 per chip. It's just the way they function. So I can get that again. Okay, there it was. So should be able to see pins lighting up here. Okay, finally. So I have my red lead on one of the commons we found, and now I'm putting my ground elsewhere. So now I can see, I can detail that, first of all, where both my anodes are, because I know that by continuity, and then by pressing this here, I know that that's segment D, because it goes A, B, C, D, E, F, G, clockwise. G is in the middle. So I want to leave my red probe here, and then go along, and maybe I'm not giving enough voltage. Oh, I don't think I have my lead in good enough. Sorry. I just want to go along and light up my leads, and you can detail the pinout this way. Like so. A, B, C, D, E, F, G. And then you have, I know where my 5 volts are, I know that's common anode, and then keep this along with you. Now I will plug in my Uno, my printer cable. And I've got some code I'll explain to you guys in a bit. Okay, so now you can see it 7 segment counts up to 9, holds it for 3 seconds, then restarts. Pretty simple, but fortunately it takes a whole microcontroller to do this. I have my digital I/O here, 0 through 8 used. I'm using a total of 9 pins. And what you want to make sure you don't, if you need 5 volts, make sure you don't just take 5 volts from the board and bring it to the 7 segment. Make sure you use a digital I/O, because that can cause problems downloading to the board. Be sure to turn your multimeter off. Save batteries. Yeah, if you need 5 volts, use it. Set one of your I/O to an output, and that'll puts out 5 volts. And don't just put a resistor to 5 volts on the board, otherwise you'll have issues downloading to the board. For whatever reason, it doesn't allow you to load programs in the Uno. So I have what you want to do is looking at your pins. I just start with A. I make A0, B1, all the way up to G. So what is that? 7 pins, and then I make the 8th pin the decimal point, and then I make the 9th pin the 5 volts. Hi, so this is my code. You see I have common anode is true. If yours was a cathode, you would set that to false. This is your anode pin / cathode. If you use different digital I/O than me, just make sure you update it here for the 7 segments and the decimal point. Here you can see I have 2 arrays with 10 by 7, one for cathode, one for anode. Because anode is powered by 5 volts, you see that both are opposites of each other. It's just the way it works. Otherwise, you would get the inverse of the numbers you're trying to see. So you shouldn't need to mess with these at all. 0 is low, 1's high. So the setup runs once, and then the loop runs constantly. So in the setup, we set all segments in the decimal point as outputs, including the anode pin. Then we write the decimal point to 0. Because we're using 1/7 segment, I don't use a decimal point at all. So if it's common anode, then I write the anode high. So it's high constantly, supplying 5 volts to the 7 segment. Otherwise, it'll just be low the whole time. I haven't tested it with a common cathode 7 segment, but I think it should work. And then likewise, for the decimal point, I reverse the states if it's common anode with a function just for the decimal point. And then I have another function here that writes the number you're seeking to see. So if it's common anode, you use the anode array, and the cathode array. And so based on the digit, you basically write all 7 segments of the array up here, A through G, 7. So whether it's high or low, for one number, you write 7 segments. And then here in the loop, I count 0 to 10, well, to 9. And I write a number, and then wait a second, then write the next. And then after writing all 10 numbers, 0 through 9, I wait 3 seconds, and then it restarts. So I'll have this code for you to download from Dropbox, and take care and God bless.